All right. I think we can start. I see new names joining us. Hi, everybody, all the partners, team members of Hello Robo. Um, so let's kick this off. We'll share the recording after this call with everybody, but I'm super happy and delighted to present you guys Andrea Piccinno. I saw you probably a couple of months ago on Instagram. Your account really liked your story. I'll give a short Shakir version of introduction. Andrea is building a really complex exoskeleton and also has his startup. He'll talk about it a little bit later. And yeah, I'll give the mic to you, Andrea. Welcome to Robo Radio 11, and we're happy to listen.
Yeah, thanks. Thanks a lot, Shaq, first of all, and very glad to be with all of you here. I'll present briefly myself. Maybe I'll share my screen so we have something to follow while I speak. Yeah, you should see my screen now.
Mm-hmm.
So, I'm Andrea Piccinno, as Shaq introduced, and yeah, something about me. As he said, I'm building an at the moment in my home. It's a long story, but yeah, I'm a mechanical engineer as a background. I graduated in mechanical engineering here in Turin. I also studied computational mechanics in my past in Germany. And then I started to work about 10 years ago in aerospace and today automotive field. But I always had this passion, let's say, for exoskeletons, robotics. So at a certain point, I decided to do it my own. I started to study this field, get informed, because at the time when I was studying, there was nothing focused on this specific field, let's say. So I try to do it my own in the free time at night and so on. And then it came a point where I decided to start to build it. Why? There are many reasons why I did this. Mostly, I think I see exoskeletons as the biggest achievement in engineering because they interface with our body. So they are really like the merging point between machines, let's say mechanics, which is the field I love, and the human body. So they have to be perfectly designed, they have to interact in an ideal way with the body and so on. And always I have in mind something that when I was studying, my professor said he was always repeating, if something in engineering is beautiful, it works, which seems quite simple, but it has an hidden truth, let's say, because exoskeletons clearly they have to be also aesthetically pleasant. Otherwise, they could be functional, but no one would wear it. So this is roughly a background about myself. As Shaq said, now the project went further. I also opened my startup in parallel with my main job, which is still in another field, let's say, since I work for a corporate in the automotive field where I am a coordinator of the design, mechanical design. Now, focusing on my journey, my exoskeleton journey, it started all during the pandemic because I bought this. I had my 3D printer at home, a very beginner one, and during that period, clearly we were closed at home with nothing to do. So I started to design this one part of exoskeleton just for as entertainment for myself as a personal challenge, and start to 3D print it at home. And it was this one that you see here. It was mostly the knee part. I wanted to see where someone could arrive just in his house with basic tools, with a 3D printer, what could be achieved. But the result was quite entertaining. Let's say I started to post something online to show it to people. It worked with its limit, but it worked quite okay even being a prototype. So I said, okay, let's go from the knee to the leg, and then to the whole lower body, upper body, and so on. Keeping all the system just passive, just a mechanical structure, which I could produce with basic tools and with 3D printing and some other passive elements. Nothing at the moment electronic or controlled, let's say. So from there, slowly, I started with this printer at home to build piece by piece, and I arrived to have a full body prototype, which was quite bulky at the time, but it had its own functionality. And I was actually quite surprised of even its resistance and functionality because I was not expecting this from a prototype. So I built this first version, and as I said, I started to post online on different communities, and the project was quite appreciated and started to build a very big community with a lot of followers, a lot of people asking information because it was so easy to produce, let's say, even for someone at home just with a 3D printer, that some of the modules could find a really big applications for even for someone in need or someone who wanted to test it. And I even decided to open source this version of the project that people could just take the models, customize, and try to play as I did at the beginning, you know? And in parallel, as I said, I built this prototype. The community was growing, having some interest about the project. So I said, okay, I did this first version. Now let's go to the second one. So something more optimized, let's say, less bulky, something with which I could start to move and even test more and see the capabilities, still keeping it 3D printed because that was the possibilities that I had at the moment. So I kept going and I achieved this second version that you see here, which was which had the same working principle. So a full body exoskeleton supporting the whole, all the joints of the user, supporting the weight that the user was carrying and relieving all the joints. But it was, as you can see, much more thin, let's say. Even wearing it was much more comfortable. You could move easily. So it was really, really optimized, this version. At that point, the community was even growing, so I started to have a lot of partnerships with some brand that you probably know, some relevant. And thanks to these partnerships, I could start to even improve the project and not only have a basic 3D printed version. So I started to introduce better mechanical elements. I had some parts machined out of metal. And I started, as a beginning, I started to improve this exoskeleton only on some modules, thanks to these partnerships that I had. But then the project continued and went farther and farther, and I arrived today to have the full body completely metal. So it's a quite totally functional exoskeleton that allows you to carry weight in pretty much every part of the body and feel it lighter, basically. It works like normally they are called anti-gravity system. It's a prototype made on myself, but from the functionality point of view is very similar to what you see on the market. The particular aspect of this one, it interests, even if it's modular, so you can choose to use only one leg, one arm, or only the lower body, upper body. It's the product at the end, it's the full body. So you can theoretically have every module, every part of the body supported at the same way. And at the moment, it's still completely passive. So basically, there are elements like springs, pistons, and so on that store energy when you move in a certain direction and release it in the opposite. So if you think to move in the direction of gravity, you will store energy, let's say for free, because it's your weight that helps you to store energy. And then you release it in the opposite direction and it makes you feel that weight lighter. So that's where I am today. I have this full body completely made out of metal that is functional. You can see here some videos that show, they are also on my profile that show you, for example, if I, let me load it. For example, you carry a bag, you place some weight in a bag that normally you would carry on your shoulder and would be not super heavy, but if you carry it for a long time, you would feel it. In this case, it's totally loaded on the exoskeleton. So you basically don't feel it and you can theoretically stay the whole day with this because you you're not feeling anything on your body. So that's the purpose of this product and prototype in general. There is now a lot of interest about this. I'm getting a lot of interest from companies and so on, or different people that wants to test how to use it. And for this specific reason, as Shak said before, I launched my startup with also three other people that I knew along the path. So we have pretty much all the figures, all the competencies also in the startup. And at the moment, we started to focus on the neck part. Why the neck? That is the one that you see here. The neck is the part that at beginning I designed and built for entertainment, let's say, because I wanted the full body, so I wanted to have also the neck. But thanks to the community behind it, it was the part that got most of the interest unexpectedly, because they apparently there is nothing like this part on today existing, and it can be used either to support the neck of the user or to train the neck. For example, there are many sports where it's important to make neck training and so on, and today is made with in ways that are not so optimal. Or as the rest of the exoskeleton does, if you have to wear something heavy on your head, you don't carry it on your neck, but it's the structure itself that bears the weight of what you have. Yeah, and so the name of the startup is now is Zeta Industries. As I said, we are now focusing on the neck, but the goal is slowly to go to exactly the starting point, which is the full body for which I have a prototype now. So this is roughly very quickly the journey that I had. It was very entertaining, full of challenges, and mostly it was unexpected that starting from a piece like the one that you saw at the beginning, which was just one leg, I never could imagine or expect to come to this point, since I started it purely for personal entertainment. But yeah, that was a surprise for me, but a very good one. If you are curious or about some specific aspect of the build, let's say, or anything you want to know in detail, I can for sure stop or focus on some specific.
Yeah, thanks so much for sharing your story, Andrea. I think this is amazing. Amazing to see where you started, where you landed, and where, I guess, not just landed, where you're going. What's the ultimate goal? What's your, like, I don't know, final checkpoint with this? Do you
Mhm.
see it? Yeah.
When I started to build, honestly, I was thinking to myself when I am hopefully 90 years old, and I didn't want to walk with the devices that are used today. So I was imagining myself in some years wearing something like this and still be able to walk, maybe not like today, but decently, no? Uh,
Hmm.
so yeah, the main goal is that it's always entertaining for me to see where engineering could push the human potential, the human body. I don't I don't like to think to engineering or machines replacing us, but merging somehow.
Yeah, I love that thought. You mentioned you were surprised that the Vertex, the product supporting the neck, kind of took attention. Which part of
Mhm.
the exoskeleton you were expecting to be gaining more attention?
Honestly, the probably the arms, because it's the one you see the most. No, they're the one that more are, let's say, commercial from a certain point of view, is the thing that normally people start to build the arm because it's the one that you directly perceive if you grab a weight. But no, it didn't happen, and honestly, the neck was really getting a lot of attention. Then I started to research, and also with the rest of the team, we found out that really there is no device today allowing to do what this neck exoskeleton is allowing you to do. There are
Gotcha.
training devices, there are training equipment for the neck, but they are different. not optimal like this. And plus, being an exoskeleton, it allows you also to not only train, but also to carry something because there are many fields where to have to wear, for example, heavy headgear. And even if it's you don't notice it immediately, if you use it over time, then you will have some repercussion, let's say.
I see. Back in school, I used to train, I used to do wrestling, and there is a specific
Yeah,
set of exercises to make your neck really strong. And I feel
yeah.
like this could be a really good use case to kind of train your neck
Yeah, in
muscles.
fact, that's exactly where they are asking now. We got some prototype produced to send both in some clinics that make rehab, so training exercises, and some
Hmm.
others are being asked, for example, in Formula 2 or fighting sports. It's exactly the one that you
Nice.
mentioned. Yeah.
That's amazing. Cool. Let's switch to Q&A. We have more guests additional to our design team. This is open format, guys. Feel free to ask any questions. Yeah, any questions.
Yeah. What was the hardest part of the exoskeleton to make? Like to come up with a solution for it?
The most difficult point was non-specifically, if you take each of them, the difficult
Mm.
part was to merge them. Because even today you see exoskeletons for the shoulders, for the knee,
Yeah.
for the hip. And when I was doing each piece singularly, was, let's say, everything quite smooth, no? You build a couple of iterations maybe, but then it was quite easy. Then when you put them all together, even if you think that you have taken all the measurements and so on, you start to move, you notice that all the joints in the full body moving together, for me was the trickiest part.
Yeah. Do you
Mm.
have had to study like a human biology, like the
In
build of
part,
a real
yes.
skeleton? Yeah. Yeah.
Yeah, I got a couple of books of human anatomy
Okay.
to see also, because some joints are easier. You see, it's very common to what you see.
Yeah.
Some others, since you have to place them outside of the body, you cannot replicate what's inside. So you have to figure out something that stays outside, moves in all the degrees of freedom, and still doesn't block you, let's say.
Yeah. Yeah. Because I can see that even on the neck part, it looks like a spine, but outside of the
Yeah,
person's
for example,
body.
the neck, if you see the neck now, you see, hey, it's quite easy, looks
Yeah.
quite easy.
Yeah.
Instead,
Yeah.
when you start to place it, you cannot move the head somewhere, or when you turn it, it's more complicated. Even the position on the back, it's a specific one. So
Yeah.
for me, the biggest challenge was to place all the parts in the correct point and mostly to have them all together. When you have this, the one that I showed you before, for example, this
Yeah.
plastic prototype, it happens more than once that I made all the parts perfect. Then I put them all together, I wear it, and I hear something cracking because even if on the simulation was everything correct and the model was
Yeah.
everything perfect, as soon as you wear it and you start to move a bit, not statically, let's say, you make a jump or you try to run, something cracks.
Yeah.
How
What were
many
you? Go
and
ahead,
did it,
Hannah.
yeah,
Yeah, yeah,
how
go
many
ahead.
iterations did it take to create a neck, for example? Because like I
So
see that this is
I,
a,
I I
yeah.
didn't hear the first part, sorry.
Oh, how many iteration did it take to create a spine, like the neck spine,
The
for
neck.
example? Yeah.
If I count in total, three, let's say.
Oh, that's super
The,
fast.
the
You're
biggest part
genius.
was no, the first two, let's say, included some sub iterations, but that was
Mhm.
the trickiest part, no? Then from the second to the third, it was easier because we got also feedbacks from clinics and use cases, so they were more minor tuning, let's say. I said three, but from the first to the second, it was huge changes. So it was very slow going from the first to the second. I call it one iteration, but in reality, it was
Yeah.
in between maybe three or four more sub iterations. But yeah, it's one of the smallest part module, let's say the neck, but it was one of the longest to develop because it's the head is probably one of the things you perceive the most because you move a lot with your head. So if it doesn't move properly, you will immediately feel there is something wrong.
We have a question from a design team. Let me read it. We noticed you have a quote that says, "If it's beautiful, it works." How does it actually show up in your work, and how does it influence your approach to the process? It's a very philosophical question.
Yeah. Let's say that the aspect behind this sentence is, if you notice, if you use the right, let's call it proportions, or you put the right numbers when you design your model, if it looks harmonious to the eye, let's say, you're almost sure it works. It's not philosophical, but if you go deep inside, there are many proportion numbers that they are put in the correct way and they make you look the object properly harmonious, and you will see that the functionality is okay. They are, it's tricky, but they are really connected. In my work, normally especially designing the whole body, I try to, for example, place the joints in the correct position, calculate the forces in the right way to have the support that I need as points. But after that, the aesthetic part, maybe you will see some pieces that you say, but this is not necessary or it's over-engineered. No, to design the specific part, I take put a lot of attention to the aesthetic too. Because as I was saying before, it's if it's functional, but it's ugly, let's call it ugly,
Mm-hmm.
I'm the first one who doesn't want to use it, even if I feel that it's functional.
I love that. Another question from Federico. Do you expect to power this at some point?
To power it.
Yeah.
Maybe. Mostly I'm going for the passive way, let's say. I am getting some requests from, let's say, modules that are already power existing to try to implement it in mine. Honestly, when it comes to exoskeletons, I'm not a huge fan of powered systems because they interface with the body. I also tried some of them. Even if they are really well done today, you will always feel that very small delay between what your body is asking to do and the actuation.
Mm-hmm.
It's nothing tragic, but you feel it, especially when you move fast and dynamically, because they are always external system that sense your movement. So
Mm-hmm.
if you have a separate robot from your body, it's something, okay. But if you have a system interfacing with your body, you will always perceive this small delay that in some situation you could ignore, in some other situation it could be not optimal. So maybe I will power some modules, but ideally I want to keep it as passive as possible. I will add some powered parts, but not to directly actuate the system, to maybe change the preload as I'm doing on the arms, for example.
Mm-hmm.
If I want to move my arm freely, there is a motor which unloads the arm, for example. If I want to have support in my arm, there is a motor which preload the arm, but then the support is still passive. So the actuation part is just to change how much the whole system is preloaded, not to provide the assistance itself.
Mm-hmm. Tell us a little bit about, I know there are a lot of videos, but one thing we don't hear is the sound. How loud is the system? How much is it important for you to pay attention at this step of the process to sound,
Mm-hmm. And
to noises?
now is the thing I will focus the most of my attention now, ergonomics and sound, because now it's being fully metal, and since I'm using just bolts and normal screws, it's quite loud when I move. It looks like I'm
Mm-hmm.
moving with exactly like a machine.
Mm-hmm.
So it's now that the functional is 90% ready. I can move. I'm feeling comfortable running. It's quite comfortable also. I have to focus a lot on all the connections to reduce the noise and ergonomics also, because there are some contact parts which are quite hard. So I have to add interfaces between the exoskeleton and the body and so on.
Mm-hmm. Gotcha.
The neck, which is the most advanced, is quite optimal. There is only one part which is a bit noisy, but it's a noise related to the fact that it's a 3D printed structure. As soon as we, for example, switch to other technology, it's going to be solved.
Gotcha.
Yeah, you
Any
mentioned,
questions? Mm-hmm.
yeah, you mentioned the delays like between what I'm like going to do and the exoskeleton. Is there any more things that make you feel like this is not my body, this is something, artificial? Have you faced anything like that?
With this system, which is passive, much less than the one that I tried that are, for example, actuated. Because when you have a passive system, it's like you're wearing a coat, another dress, and another layer. So you feel something external, yes, but nothing that it's moving you. You are always the one moving. You will feel some resistance in some direction. You will feel some assistance in other cases, but your brain still accept the fact that you have fully control on the system. The main issue is when it's actuated, that if in some situation you have some delays, your body will perceive that there is this delay or this external system. But if it's a passive one, for sure you feel something because you are wearing something that, especially in the connection points. For example, I have connections in my hands, in my arms, legs. So you feel something, but it's like you have a glove, you have a pair of shoes, an additional pair of shoes, nothing extreme, let's say.
I was
Mm.
thinking also about in your example with the back handling, I figure out that it is more about like the assistant of current usage, and in the example of sport, it's like making your user stronger. Were you thinking about like the use cases of pushing the human limits? I don't know, maybe you were already doing something, or like I was thinking about computer games or something like this where the world became completely different. What is this? And in case you like your next thing to push the human limit, what it should be.
Because my phone fast. Okay. With passive system, the good point is that you are very free, let's say, to choose. Because when I think mostly to the load-bearing capacity of passive system. No? So they allow you to carry weight, to be very simple, and not feel them, or at least you don't feel the whole weight. So that's for me already an enhancement. If you were carrying anything for half an hour getting tired, now with these systems you can do it for 3 hours, for example. So for me that's the main enhancement. But also getting feedback from the community or from some specialists, you get some ideas like the one that you mentioned that are, for me, for example, were unexpected at the end. So if you have a passive system, you can use it as input for virtual reality, for example, or instead of having the exoskeleton carry the weight for you, since it works with the resistance principle, you can use it to train, as it was requested for the neck, for example. And in theory, what we are doing for the neck, it can be done with every part of the body. So if your arm resists in one direction, you could use it to train in that direction. Honestly, I don't see it happening with the whole body, because I don't see why someone should wear an exoskeleton to train if you can train in other ways. For the neck, it's easy because it's small, it's very practical to wear it, and there is no other way to train the neck in this way, let's say. But for the rest of the body, I don't think that an exoskeleton will be used for training, but for carrying weight, yes.
Mhm.
You mentioned about simulation, and I think in robotics development, there is always a huge, not only robotics and in prosthetics, obviously, too, there is a huge gap between, let's call it hypothesis, your expectation, and then reality when you actually on the field testing the product. Tell us a little bit about your simulation process.
Mhm.
What are you using? What do you expect to validate during simulation? What are the gaps? And you're like, I wish I
Yeah.
thought about this during simulation.
Normally, the approach I try to do since the first prototype is the process is simple. So I take my body, I 3D scan my body in different positions, no? Not only standing, also in the position I want. Then I have my 3D model with all the joints connected properly on the software I use. Normally, it's Fusion, for example. So I place all the joints movable, and I try to. My simulation consists in having all the movements, all the positions in which I scanned myself with the exoskeleton placed properly. So I know that all the joints allow me to achieve that position. That's what I try to do in simulation, and it works 80%, let's say. Because when you wear it, there will always be an intermediate position between the two that I scanned that was not considered, and the joint maybe is not following exactly the path that it should. So that is the most tricky part. That's why before I was saying placing all the joints together is the trickiest. Because even if you 3D scan yourself in 10 positions, to go from the first to the second, there will always be some intermediate, and you are not exactly sure that the joints that you designed in the exoskeleton will follow the path that your body follows.
I see. One more question. Let's say Vertex has commercial success. You have to scale it. How much have you thought or already thinking about adjustability? Are there preset sizes, or it's like one size fits all?
Mhm. No, for the neck, I think we found the ideal way. There are two models now. So with
Mhm.
one, you can cover the size small and medium, and with the other, you cover large, extra large. It works quite okay because the neck, yeah, between people is different, but not a huge difference like can be in a leg, for example. So the range of motion is pretty much stable with these two families. And the adjustability on the neck, it's related to the soft textile part that you see here because it's attached to the body with a helmet.
Mhm.
Now it's like a rugby cap, no? So that depends on the user and
Mhm.
the brace that you use also. Two sizes could fit most of the people.
Gotcha. I really like the pattern you chose for the helmet itself. It's
Yeah,
pretty cool.
it's
Um,
at the moment is a rugby cap. It's okay. I mean, it's comfortable. It's hot
uh,
because
uh,
it has protection, which is not really needed in our cases. But yeah,
mhm.
the goal is to find a partner that can design also the textile parts, so we can also have our custom ones.
Gotcha. Any other questions in the
Yeah,
audience?
I have a question. Where do you uh, like search inspiration for these beautiful exoskeleton parts like this neck? Maybe you use nature or sci-fi movies, something maybe
Mhm.
super crazy. Yeah.
For the whole body at the beginning, at the beginning didn't have the neck. I got inspired by all the movies around, let's say, and also some commercial exoskeletons that already exist. So I try to pick the best from each of them and also add a bit of my taste. Some parts were that had to be functional. I imagined them new. For the neck, it was purely imagination, let's say. I wanted to, because I didn't find anything specific for the neck. There is a TV series that has something like that. So I found out later that this series existed and it's very similar. So it was not on purpose. But yeah, the neck was the only part which came completely from scratch, let's say. It's
Which
very
TV series is it?
Cyberpunk, I think is the name.
Mm-hmm. It
Okay.
looks
Yeah.
like from Cyberpunk. Yeah.
Yeah, when I
Okay.
found out later, I said that it's the copy. I have to watch
Okay.
it to understand why.
Okay. You mentioned movies. What movies you were inspired with?
Mostly Elysium.
Oh, okay.
Yeah.
Mm-hmm.
I mentioned Iron Man, but there is nothing in Iron Man of this. But the dream, let's say, is always that.
Gotcha. Okay. Yeah, Elysium is a cool movie, actually.
Yeah.
Uh, all right. Any other questions, teams? Um, okay. I think this is it. Maybe I'll end with one question. Clearly, as it sounds, you didn't study specifically for this, and your life brought you to this point. But looking back at school times or university times, what is one subject you wish you studied so this work could have been better?
Mm, Actually, it's probably a whole faculty, let's say, all the biomedical engineering part, which puts a lot of attention and courses to the human-machine interfaces. That, at the time where I was in the specific university, there were no classes focusing on this.
Mhm.
It was the very mostly basic ones. So that's why my course of study was generally mechanical engineering. And today, in the same university, there are even classes focused on exoskeletons. So there is much more, but 10 years ago, more, 12 years ago now. So I
Gotcha.
think that having done that, probably at least I would have started before this journey.
Gotcha. Cool. Awesome. It sounds like we have no more questions. Andrea, thank you so much for sharing your journey. Really amazing
Yeah, to
project.
you.
We
It was
yeah,
really glad to be with you all and to get all these questions and being able to share how I arrived until now.
absolutely. Yeah. We're going to be looking closely to the path of your company, sharing updates with us, and we're happy to promote it. And again,
When's the
we'll join you.
deadline? Is it today?
Oh, I think now you're.
Oh my God.
Hold on. Okay, we have a Bedrock team not muted. Now, can you mute yourself? Nice. But yeah, thank you so much. We'll follow you on Instagram, and yeah, this was amazing.
Same for
Um,
me. Yeah,
yeah, cool. Talk to you
Thanks a
soon,
lot.
Andrea. Thank you.
yeah, talk to you.
Yeah, have a
Bye.
good
Have a
day.
Yeah,
nice
thank you.
day.
All right.
Bye bye.
Bye.
Bye
Bye.
bye.